Hi, Mr. Richards here, and today's lesson is on similarity and transformations. Recall that a dilation changes the size of a figure by a scale factor, but does not change the shape of the figure. Since the size is changed, the image and the pre-image are not congruent. When you think about our other transformations, from translations to rotations to reflections, those all resulted in still congruent figures. But since dilations change that size, well, it's no longer congruent. Now complete the graphic organizer. Consider each word on the rating scale and place a check in the appropriate column next to the word. If you do not know the meaning of a word, find the meaning in the glossary or on the internet. And so our rating scale, we have know it well, have seen or heard it, or just no clue. And you can go ahead and check for yourself dilation, scale factor, and similar figures. Here are the vocabulary words definitions. A dilation is an enlargement or reduction of a figure. Scale factor is the ratio of the length of a side on a scale model to the same side of the original object. And similar figures are two figures that are the same shape but may have different sizes. Now, if you need to go ahead and write these down, go ahead and pause the video now before we move to the next page. Two figures are similar if the second can be obtained from the first by a sequence of transformations and dilations. So in example 1, determine if the two triangles are similar by using transformations. Now, since the orientation of the figures is the same, one of the transformations is a translation. So step 1, translate triangle DEF down 2 and 5 to the right so that D maps on to G. So we're going to go, all right, from D, 2 down and 5 to the right, so D maps on top of G. And once you do that, that's what it would look like, where you would have new D there, new E here, and new F there. Now it says write the ratios comparing the lengths of each side. Notice how they took HG, which is the longer side, and that's 8 long, compared it to 8D, which is 4 long, which simplifies to 2 over 1. GI, they said, was 6. DF, they said, was 3 if you count, and that also simplifies to 2 over 1. IH is 10 units. FE is 5 units, and you can solve that using the Pythagorean theorem. That also simplifies to 2 over 1. And since the ratios are equal, triangle HGI is the dilated image of triangle EDF. So the two triangles are similar because a translation and a dilation maps triangle EDF onto triangle HGI. So in summary, if we can have a transformation followed by a dilation, the way we'll check whether or not we can do a dilation is to compare the ratios of the sides. Determine if the two rectangles are similar by using transformations. Now the orientations of the figures are different. You can notice how one's, well, turned. So one of the transformations is a rotation, and you can see where they rotated that up. Now, write ratios comparing the lengths of each side. They compared WT, which is right here, WT, which is 5 units, to XY, which is 7, 5/7, and UV to ZW, and that's also 5/7. So far we're okay. But our problem is TU here with YZ, that's 3/4, and VW to WX is also 3/4. And so these ratios are not equal. So the two rectangles are not similar since the dilation did not occur. If we have, like we did in example 1, equal ratios, then we can create a dilation. If we do not have equal ratios, we cannot. So now we get to try this out on our own. We have triangle STU and triangle PQR. Well, this looks like the smaller triangle is a reflection of the larger triangle. So if we were to kind of draw a line here and reflect our STU over that line, our new S would end up right here. Our new T would end up right here. And our new U, well, let's make sure we can count that out. From U, we're 1, 2, 3, 4, 5, 6 spots. So we need to go 1, 2, 3, 4, 5, 6 spots, which puts us right here. And that's our new U. And now if we connect those, we can see that our orientation is the same. So the first transformation that we performed was a reflection. Now, can we do a dilation? Well, we need to compare the side lengths. And if we compare now PQ to our ST, PQ, if we were to count, is 6 units. And again, the way we can count is 1, 2, 3, 4, 5, 6 units long. ST is 1, 2, 3 units long, so that's 6 over 3, which simplifies into 2 over 1, which is just 2. Now what about our QR? And if we compare that to TU. Well, QR is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long, compared to TU is 1, 2, 3, 4, 5 units long. And that once again simplifies into 2 over 1, which is just 2. Now the tricky side is SU and PR. So we're going to have PR compared to SU. Now, in order to do that, we're going to have to use our Pythagorean theorem. So to get our smaller one, our SU, if we use a squared plus b squared equals c squared, the length of ST was 3, the length of TU was 5, and that needs to equal c squared. So 9 plus 25 needs to equal c squared. That is 34 needs to equal c squared, and if you take the square root of both sides, you'll get about, and we'll round here, 5 and 8/10. So our SU is 5 and 8/10. Now, what about our PR? Once again, if we used a squared plus b squared equals c squared, our PQ is 6, our QR is 10, and that needs to equal c squared, so 36 plus 100 equals c squared. 136 needs to equal c squared. And if we take the square root of both sides here, we end up with, again, rounding to the nearest tenth, 11 and 6/10 is about equal to c. Now, as it works out, 11 and 6/10 divided by 5 and 8/10 is once again 2 over 1, which is 2. So it does appear that we do have a dilation here. and it looks like we multiplied it by a scale factor of 2. So we can say for our answer here, yes, these are similar. And the reason why is we have a reflection followed by a dilation with a scale factor of 2. So again, we reflected it, and then we checked the ratio of the lengths of the sides and came up with 2 for all of them. So that's how we know it's similar. Now in our next example, the orientation of ABCD is the same as the orientation of EFGH, so we do not need to think about any type of reflection or rotation. There's going to be some sort of translation, perhaps, but let's check the ratios of the side lengths first here before we think about any kind of translation. So if we can compare first the length of AB to the length of EF, AB is 1, 2, 3 units long, compared to EF, which is 1, 2 units long, and that just simplifies to 3 halves. And then if we can compare our, say, AD to the EH, AD is 1, 2, 3, 4, 5 units long, and EH is 1, 2, 3, 4 units long, and 5/4 simplifies into 5/4. So right now we can already tell that our ratios are not going to be equal. I mean, after all, 3 halves, if we multiply by 2 on top and bottom, is 6/4. And 6/4 is not equal to 5/4. So our answer for this question on whether or not these are similar is no. And for our explanation, the ratio of the side lengths are not equal for all sides. So when the ratio of the side lengths are equal for all the sides, we have similar objects. When the ratio of the side lengths are not equal for all sides, we do not. Now for the second half of our lesson, we're going to use this scale factor. We calculated the scale factor, or the potential scale factor, in our first 2 examples to see if we had similar objects. Now, if we're given a scale factor, can we use that? So similar figures have the same shape but may have different sizes. The sizes of the 2 figures are related to the scale factor of the dilation. So if the scale factor of the dilation is between 0 and 1, then the dilated figure is smaller than the original. If it's equal to 1, well, if we multiply all the lengths of the sides by 1, it's going to be the same size as the original. And if we multiply it using a scale factor larger than 1, well, it's going to be larger than the original. And in our guided example here of this cute puppy, Ken enlarges the photo shown by a scale factor of 2 for his web page. He then enlarges the web page photo by a scale factor of 1.5 to print. If the original photo is 2 inches by 3 inches, what are the dimensions of the print? Are the enlarged photos similar to the original? Well, the first step is to take our original photo and multiply by the scale factor of 2 to find the dimensions of the website photo. So you could see here where we went 2 times 2 to get the 4, and the 3 times 2 to get the 6, since our original dimensions were 2 by 3. So our new dimensions are 4 by 6. Then, so the website photo will be 4 inches by 6 inches. Multiply the dimensions of that photo by 1.5 to find the dimensions of the print. So we took the 4 by 6 and multiplied each of those by 1.5, or 1 5/10 to get 6 inches by 9 inches. So the printed photo will be 6 inches by 9 inches. All three photos are similar since each enlargement was the result of a dilation. So can we do this ourselves? An art show offers different size prints of the same painting. The original art measures 24 centimeters by 30 centimeters. A printer enlarges the original by a scale factor of 1 5/10, and then enlarges the second image by a scale factor of 3. What are the dimensions of the largest print? Are both of the enlarged prints similar to the original? Well, our original print was 24 by 30 centimeters. And the first thing we did was enlarged it by a scale factor of 1 5/10, so we can multiply these by 1 5/10 each. And when we do that, our result is 36 centimeters by 45 centimeters. That is our new one for the printer. And then enlarges the second image by a scale factor of 3. So we can take the 36 centimeters and the 45 centimeters and multiply each of those by 3. And so our result for these is 108 centimeters by 135 centimeters. And so what are the dimensions of the largest print? We can say for that one 108 centimeters by 135 centimeters. Now, are both of the enlarged prints similar to the original? Let's tie this all together with checking the ratios of the sides. The first image was 24 by 30. The enlarged image from that was 36 by 45. Now, if we compare the ratios of these sides, we would have 45 compared to 30, and we would have 36 compared to 24. Well, 45 compared to 30 simplifies to 1.5, and 36 compared to 24 simplifies to 1.5, and sure enough, that was our scale factor. And so since they're the same, as they should be, since we just multiplied by the same number, these are similar. What about the original, though, the 24 by 30, compared to our super enlarged image of 108 by 135? Well, again, if we compare these, the 135 over the 30 and the 108 compared to the 24, these simplify when you divide to 4.5. And so, since the ratio is the same, then we can say, yes, these are similar figures. Now, to answer that last question, we can answer it by saying, yes, the ratio of the side lengths of the original compared to the enlarged were the same. And that is it for this lesson on similarity and transformations. Good luck.